Hi everyone, my name is Sui from Group 7, Section 1. Today, I will be demonstrating an AC to DC power supply circuit using Multisim. So first, let me list the components used in this circuit. An AC voltage source with a peak voltage of 50 volt and 10 Hz. A step-down transformer with a turn ratios of 5 to 1. A full-wave bridge rectifier. I'm using the B4B42 component in Multisim, which consists of standard silicon diodes with a forward voltage drop of about 0.7 volt. A capacitor with a capacitance of 100 microfarad. A Zener diode. I'm using the 1N47338, which has a Zener voltage of 5.1 volt. A current limiting resistor for the Zener diode, which set as 100 ohm. A load resistor with a resistance of 1500 ohm. And lastly, a ground connection. Okay, so now let's connect all the components accordingly in Multisim to build the complete circuit. First, connect the AC source to the transformer primary winding. Then connect the secondary winding to the bridge rectifier. The rectifier is then connected in series with the smoothing capacitor. After that, the capacitor is connected in parallel with a current limiting resistor and Zener diode, and finally connect the load. Okay, so now, here's the circuit works. First, the step-down transformer reduced the 50 volt input voltage to 10 volt, according to the 5 to 1 turns ratio. Next, the bridge rectifier converted the AC voltage source into pulsating DC, and this is the rectification stage. The capacitor then filters out the fluctuations in the rectified voltage, producing a relatively smooth DC output. The Zener diode with its Zener voltage of 5.1 volt helps maintain a stable output voltage. A series resistor limits current to protect the Zener diode from excessive current. The load resistor represents the device consuming the power. It also affects how the capacitor discharges. According to the time constant tau equals to RC, a higher resistance value allowed the capacitor to discharge more slowly, reducing ripple. The smaller the ripple, the better the filtering. Okay, so now let's simulate the circuit and observe the output waveform at each stage. Okay, I will place an oscilloscope and connect the channel A to the output of the step-down transformer. Okay, let's see the waveform. It's a perfect sinusoidal waveform, alternating between positive and negative half cycles. Okay, then we connect the channel A to the output of to the terminal of the capacitor. Let's observe the waveform. Okay, a DC voltage with a ripple, and this confirms the filtering effect of the capacitor. Lastly, I connect the oscilloscope to the terminal of the load resistor to observe the final output voltage waveform. We can see that the output is a constant voltage around 5.1 volt, which matches the Zener voltage, indicating that the regulation is working perfectly. That's all from our group. Thank you.